Right, so today we're going to look at elimination reactions. Now you have the summary there, so we can work with it. What addition is making an unsaturated hydrocarbon a saturated hydrocarbon? What do you think elimination will do? Yes, you're going to move from a saturated hydrocarbon, you're going to move to an unsaturated hydrocarbon. So you're going to remove atoms from the molecule. So elimination reaction means you're going to remove atoms from the molecule, and then the single bonds will turn into double bonds. And remember, it's the single bonds between the carbon atoms. So atoms will break from the carbon reactions. So the first one I want us to look at is cracking. Yeah. If you turn in your textbook to page 132, you'll see cracking there, and you'll read the aim of cracking. Cracking is when you take a big molecule, usually, when you take a big molecule and you break it up into smaller molecules. The organic compounds, if they're big, they're heavy, they are or like fats or waxes, or like solids, and they're not very useful. So when they extract the oil or the coal from the earth and they refine it, they take those big molecules and they break them down into smaller, more useful molecules. That is cracking, and you get two types of cracking. You get thermal cracking and you get catalytic cracking. So what is the word thermal cracking telling you?
Adding heat into it to break it down.
Yes. You get thermal cracking and you get catalytic cracking. The thermal cracking, the condition is you need to use heat. And the catalytic cracking, the condition is that you need to use a catalyst.
Are there specific catalysts that you must use for this?
You will need to look at the different situations. That dehydration of the alcohol needs a specific catalyst. Yeah. But you'll have to read the question to answer that. So with the catalytic cracking, you need a catalyst, you need low pressure and low temperature. No heat. Yeah. With the thermal cracking, you need high pressure and high temperature. That means heat. Okay. And zeolite is aluminium silicates, which contains aluminium, silicon, and oxygen. So in a zeolite, you have aluminium, you have silicon, and you have oxygen. So not platinum in this case. Aluminium Aluminosilicate is a silicon oxygen aluminium compound. Yeah, I can Google the formula, but I don't think that's necessary. Are you ready to roll? My recording is a bit messed up today. C2H4. Okay, so that's using molecular formula to write an equation for this cracking reaction, and it is catalytic cracking. Using structural formula, what will decane's structure be? Yo, can I shorten this? No, I can't. I can't. Not if they say structural formula. Then you have to write this thing out. What's the problem? Just count my carbons to make sure they are 10. Right. So I'm not going to have space to the right. I'll have to go downstairs for my products. So all you need to know is zeolite catalyst, low pressure and temperature. Even if they give you a value like 500 degrees Celsius, on industrial level it's low. And the product will be having 8 carbons and ethene, which has a double bond. ZB, are you still there? Good. So can you continue to crack the octane? Yes, you can. So depending on what you do with the products, whether you separate them or whether you continue to crack them, that will determine the products that you will end up with. Okay. Are you happy? Good. So you can also, in industry they use zeolites, but in you can also use platinum. Doesn't have to be zeolites. Obviously, zeolites are cheaper than platinum. Right. Maybe continue. I want to go to the thermal cracking. The catalytic cracking is fine. We've done that one now. I want to go to thermal cracking. Did you say okay because I can move on?
Yes. Oh, sorry.
Not?
Sorry,
Sure. thermal cracking. Our example says ethane. Oh my, but this is a small molecule. So why would they crack this now? High temperature and high pressure. And what will this break into then? Ethene and no, can't be methane. Ethene and hydrogen. And hydrogen is quite an important gas to have. Why would you think do I make this statement? Hydrogen is very important. Who eats margarine on their bread? Margarine is oil turned into a fatty substance or a solid substance through the process of hydrogenation. So hydrogen is important. Why else would I say hydrogen is important? Come on, Death by Friday science class. What? They say by 2030 something. Cars? May no longer use the traditional fuels. I don't think it will happen by 2030. That's 7 years from now.
7? How?
Yeah,
It's 2023. 9 months to Christmas. So by in less than 7 years, no more petrol and diesel in our cars.
No.
They are.
It generates too much.
I just simply don't know how they will manage that.
The industry is too large for them, so they're not going to want to do it.
Yeah.
It's too much money.
But I'm just talking hydrogen. So you have these hydrogen fuel cells. They actually use it to send rockets up into space and send things to Mars and I don't know where else. But yeah, so hydrogen is also an important source of energy. So making hydrogen is important. So they can take ethane and then through polymerization, ethene is turned into different plastics. Okay. Polyethylene. Molecular formula. Ethane is C2H6. High temperature, high pressure turns into C2H4 and H2. All three these substances are gases. As structural formula, it is CC going to C double bond C and H. Right. What's the next example of elimination? So this one is thermal cracking or cracking in general, thermal or catalytic. Dehydration. Yes. Okay, so the second type of elimination reaction is dehydration, where you take an alcohol and you remove the water and you form an alkene. Okay, dehydration. The conditions for this is heat and concentrated sulfuric acid, which is a dehydrating agent, and an aluminium oxide catalyst.
Both or just one?
All three: heat, concentrated sulfuric acid, and aluminium oxide catalyst. So choose your alcohol. Propanol. 1, 2, or what propanol? 1 propanol. Fine, we'll do both. We'll do 1 propanol. So what's the structure of 1 propanol? 3 C's and an OH. And each C will also have its hydrogens. It's a bit more tricky to use molecular formula to write these reaction equations, so they will prefer you to write the structural formula. And we have our heat. A triangle could represent heat. Okay? A triangle can represent heat. Conch, HCl, H2SO4, and Cat, Al2O3. So what do you think? Which alkene will form? Propene?
Yes.
Okay. Propene is C, C, double bond C. And H, O, H. And you said we must look at, no, but 2 propanol and 1 propanol. Oh no, it's not the same thing. 2 propanol. Okay, so 2 propanol would look like this. So what will form? Won't the same thing form?
Yes.
The same thing will form. Yes, we can. Sorry, I missed this hydrogen here. And water. So this is dehydration, an example of elimination. Right, try butanol. You can go for 1 butanol and 2 butanol. Try 1 butanol and 2 butanol for elimination reactions. So this is your homework. Elimination reactions. 1 and 2 butanol.
In the manual.